Hello everyone and welcome back to the Kia Ora Theatre at Linux Conference Australia 2022. Next up we've got Ian Wienand. Ian has been involved with OpenStack and the OpenDev collabatory for several years as an employee of Red Hat, and has admin privileges for these projects and commit privileges for the broader CI ecosystem of OpenStack's DevStack project and the Zuul project gating system. Today he's here to talk about OpenDev, a collabatory for open source software development at scale, and how its infrastructure components come together to run the services used by thousands of developers to develop key parts of the open source ecosystem. Ian is taking questions today, so make sure you put them into the questions tab and venue list throughout. Over to you.
Hello, thank you for having me here today. Will you be interested in this talk? We'll be talking about sort of continuous integration, speculative testing, things that fall under the category of continuous delivery, CD, DevOps, GitOps, Zuul, the CI/CD system, not the Netflix one, not the Ghostbusters one, gating, merge trains, pipelines, things like that. This will come together with a bit of Ansible, containers, and we're working in a Gitish environment. So if you use any of these sort of Gitish code review systems, you might find something in here for you too. Let me pick off the last bit of the title of the talk first, the OpenDev Collaboratory. What is that? Many of you will be more familiar with the OpenStack project. OpenStack's been going for 12 years, something like that. It's basically the way to run a sort of traditional cloud of virtual machines on top of your hardware. Open source, of course. What tended to happen with OpenStack, though, was over all these years, it collected a lot of projects that weren't sort of related to OpenStack. So every problem in computer science can be fixed with a level of abstraction. We started up what's called the Open Infra Foundation and split these separate projects out. So OpenStack is now one of these projects under the Open Infra Foundation. So what's OpenDev? OpenDev is the sort of section of this that provides the infrastructure services for all these projects, including now OpenStack. That's the code hosting, code review system, Gerrit, all the CI systems, all the collaboration systems, the mailing list, Etherpad, messaging, all that sort of stuff. All of that infrastructure is provided by OpenDev to support these projects. The way that we work, OpenDev provides all these services to these projects, which build these products such as OpenStack and Kata and Zuul and Airship. These are then consumed by a wide range of companies. Many of these companies then contribute back to us. So VexHost, for example, and Rackspace provide us with a lot of our hosting for hosting our services. Linaro provides us with a lot of ARM64 resources in various ways. Other providers provide us with hundreds of CI nodes that we use for running CI for the projects. And all these companies provide developer time as well. So developers that help out and help run the infrastructure. We make the infrastructure better, the projects make themselves better, the companies get better. It all sort of works in a nice circle. So that's what the OpenDev Collaboratory is, and that's the services that I'm talking about today are the services provided by the OpenDev Collaboratory. So open infrastructure, what do I mean by open infrastructure? Well, our goal is to build on open source technology from top to bottom. That's not everybody's goal, and we're sort of privileged to have this goal that we only use open source technology in our stack. What we want with our infrastructure is for anybody to be able to turn up and contribute to our infrastructure without any explicit permission or having to join the admin group or having to be part of a special group that can see the infrastructure. Sort of having your infrastructure out in the open isn't really that common, even in open source projects. It's sort of common to maybe do this at a project level where maybe you have the website checked into Git and people can update the website in Git, and you push a change, and then a little bit later a cron job pulls it in and updates the web page or something like that. but all of the infrastructure behind that, all the the web services and everything behind that, these aren't often sort of exposed publicly, and everything from the configuration to the orchestration is not open for contribution in a free manner. Even some open source hosting providers that I've seen sort of say, "Oh, we'd love your help to help admin our systems. Send us a resume." So we definitely don't want to be at this level. We want to have our infrastructure completely open, and that's the systems that we've built and that I'll be talking about today. The only way you can really achieve this is to have your deployment and CI really so close that they're almost the same thing. We call it testing, test-like production. We can accept sort of unprivileged changes coming in and test them and have a really high level of confidence that when we commit these changes, that we're really close to what is going to be pushed into production. It really allows us to run open infrastructure by taking this model, this test-like production model. A few more concepts to pick off. Zuul. Zuul is the CI system that really enables all of this. Hopefully some of you will be familiar with Zuul, especially if you've ever contributed to OpenStack. Zuul would have run your CI jobs on the change that you contributed to OpenStack. Zuul is a continuous integration, delivery, and deployment system. So it does all of these things for you. And it works on project gating. And gating is a little bit of a hard concept to explain, but we all have it intuitively in our head. And this is, you may have the greatest testing in the world. And if you commit your change and run your testing, if you propose your change and run your testing, that's fine. But if somebody else commits to the tree in front of you, then your testing is now invalid. And we all sort of intuitively understand this. And the only way to safely merge our changes, when we have more than one developer, is to really put those changes into a queue and merge them sequentially. And you need a system to help you do this. You can't have humans sort of doing this. It just doesn't scale. Zuul essentially solves this, and this is what we call project gating. Zuul's been doing this for well over a decade. Other systems now, this is now called merge trains or merge queues in other systems as well. They're sort of catching up. But this idea of gating, that it's impossible for us to merge a broken change because Zuul is merging the changes for us. Humans don't merge changes. Humans say this change is okay to merge. And then what Zuul will do is put them in a queue, run the testing in the most efficient in the most efficient manner possible, and push those changes in for us. So let's get into the details more. I've sort of gone through all these concepts, but we need to get into some details here. Today, I just want to use an example of our paste system, which is just one of our absolute simplest systems, but it'd be interesting to just walk through a couple of changes here. You're probably familiar with the paste system. You just put some text in there, you paste it in there, and you get back a URL, and you can share your paste. It's good for sharing logs and things like that. Open infrastructure, this is all open. You can go to this website here, and you can see the paste service that we run. What I just want to pull out, it builds a container. It's got a Docker file there. It builds a container. Nothing amazing. Builds a container based on Python 3.8. Okay, fine. All right, let's just keep that in our head. I'm going to propose a couple of changes here just to show you how this whole system works together, and we're going to work through the whole thing here. This is what you would see on our review site, review.opendev. This is a Gerrit instance. We're looking at the Logit paste system. This is the open changes for that. And I'm going to propose a couple of changes here that we're going to use as an example. Don't worry about the DNM in front of it. I actually proposed these to the live system. This has all been done, in the live system. DNM means do not merge. It's just an indication to reviewers, I'm doing something, don't look at this. So the first change, we're going to update the container to Python 3.9. This is something you definitely want to test, right? You're updating a container from 3.8 to 3.9. That could potentially impact your services. You want to test that. And I'm also going to put on top of that just another change, just for fun, just to show how all this cross-project testing works. Instead of saying new paste, we're going to make it say enter new paste. Let me just go back. See where it says new paste? We're going to make it say enter new paste, just for fun. Okay, so these two changes are stacked on top of each other. These two changes depend on each other. You can sort of see that in the way that Gerrit has put the changes on top of each other. So I've proposed these changes. I've pushed them into the code review system. What's going to happen next? This is the Zuul interface that I've extracted here. You can see in the queue here, I've just sort of squished it all down here. Zuul is going to pick up that I've pushed two changes, and it's going to start running some testing. You can see it's going to start running the first test on the base change, and then it's going to put the second change together with the first change and start running the testing on the second change. I'm going to call that the API change because it changes some text, which could be considered an API. All right, so Zuul's going to run its testing. We're going to wait a few minutes. We're going to come back to the change a little bit later. This is the change. I'm just calling out here that, we have this relation chain again. Zuul has run the testing. It's verified it, says, okay, all the tests pass, everything looks good, great. And so at this point, you're sort of going, okay, thanks, Ian. You pushed the change and you ran some testing. We've been doing that for a long time. That's not very exciting. And that's true. But what we've tested here is, remember, just the Logit, the paste service container here. But this is not what we deploy. There's a lot more that goes around this service that has not been tested at this point. But we need to test all this stuff in blue as the OpenDev people providing this service to make sure that these changes are ready for production. All these things in blue are really the production side of the testing here. So, all these blue bits are what you would call, system configuration. So now we come to testing and deploying the two changes that we sort of discussed before. So, system configuration, we actually have a repository where we store our system configuration called system config. This is the URL for it. And this is where we're going to jump in to start testing these changes that we've made to our service to make sure they're ready for production and ready to be pushed, into service. So I'm now going to propose a change to our system config repo. Now here's the magic. All the magic sort of comes from this one little line. We depend on that previous change, the API change, that updates the container to Python 3.9 and makes the little change. And what we do in this system config change is we update our testing of the paste service. See, you can see down there, instead of looking for the text new paste in the text, we're going to look for please enter your new paste. That was the change we made. We used down the bottom there, we use it's called Test Infra. It's a very cool project that allows you to test your infrastructure, like write unit tests that test your infrastructure. Check it out if that's the type of thing you need to do. So yeah, I'm sorry. just didn't cut, the window looks a little cut off there. So we're going to push this change. And now I kind of need to explain to you what's going to happen when we push this change and Zuul picks up this change. So when we propose a change from any of these services, Zuul is sitting there, it's listening for the changes that come in, and it prepares what we call an executor environment. So the first thing it will do is take the code from the proposed changes, and it will merge them into code trees that you need to test against. So Zuul knows the dependencies. You know, we set up that depends on before, and Zuul will merge all the code that you need to test into for you automatically. The next thing it will do is set up the nodes where you want to test. So these are ephemeral test nodes that they're just assigned and allocated to you, and they're the nodes that you use for testing. We won't talk about how those nodes are allocated. It's done by node pool, a whole separate thing. That could be a whole separate talk. We'll just take it for granted that we get a couple of nodes to test on, as many as we want. Now, at this point, right, we have a bunch of nodes waiting for something to happen on, and we have our executor environment with a bunch of code that's ready to be tested. So this is a job for Ansible, okay? We set up a job inventory that points to all the test nodes. And then our CI jobs are just Ansible playbooks. They just run against the test nodes that have been assigned. This means that your testing is written in Ansible, your deployment is written in Ansible. You know, everything is the same. If you want your testing to be a shell script, well, just make Ansible call a giant shell script. That's fine. But you can also use all the great features that Ansible has, you know, just as easily in your job playbooks as well. So we're at this point, and it's sort of over to the testing at this point. So the first thing that the test jobs do is copy the code over to the test nodes, start running the test nodes. The nodes run their tests. They do whatever they need to do. Then they return their logs, their artifacts, whatever you know has happened on the nodes that they want to return for storage and reporting back is returned back. Zuul takes that back, and Zuul reports the change back. That's the sort of high-level overview of what Zuul does in response to a change. Now, I'm going to jump ahead and actually describe how we deploy merge changes from Zuul. This will hopefully this should make sense when I get to the next slide, but just stick with me because I know it seems like I'm jumping ahead. So we now have a merged. This is how we deploy our production changes. We have a merged Gerrit change. Okay, so we trust this change. This change has been reviewed. It's been committed. It's ready for deployment. So Zuul picks this up. Same thing. Zuul starts up its executor environment. Zuul grabs the change. Now, this is now a merged change. It puts it into the executor environment. Now, the only difference is than before, instead of an ephemeral test node that is going to disappear, we connect to a Bastion host that has permission to log into our production hosts. So we set up Zuul is allowed to log into this Bastion host. The code, the merged changes are then pushed onto the Bastion host, and then the playbooks actually run the configuration through the Bastion host, but end up targeting the production host. And so that is how we do deployment via Zuul to our production services. Zuul actually does our, production deployment for us. Zuul even deploys itself. Sort of circular reference there. So this is our production deployment. So when we want to test changes, we need to test like production. What are we going to do? Well, it's all exactly the same, except instead of using the actual Bastion host that is allowed to speak to the actual production host, we just turn those into ephemeral test nodes. We use the nodes that are allocated by node pool, but we really do the same thing. So a proposed change comes in from anybody who wants to submit it in Gerrit, and we actually do exactly the same process, except it deploys onto 2 nodes that will disappear at the end of the test and we don't care about. So this is our simulated production environment. And this is really the key to how we do this test like we're in production. And this is why I say that our testing is really, really close to our deployment. It really is that close that we have a really high level of confidence that if we've passed testing, that when we push this into production, it's all going to be okay. So I want to dive into a little bit of how this actually works, give you some actual details. This is actually the job, the system config run paste. This is the actual Zuul job that is going to be testing the Logit container changes and tests the paste system. The job of interest for our situation here. So this is Zuul config, but you don't even need to really understand it. You can just see what's going on. You can see that we require the system configuration. That makes sense. And you can see that we have a node set defined here. We need the 2 nodes. This is the 2 nodes I've talked about. We need a Bastion host node and we need the production host node. And so that's what we have defined here. Some jobs might have 3, 4 nodes. They might set up a little test zookeeper system by themselves and connect up to that, all sorts of things. But this is just the absolute simplest case here of the Bastion host and just one simple production host. So I've sort of been through this, but it's still probably not making terribly much sense as to how this actually, works and pulls in the changes from that Logit container image. So there's another little thing here that sort of just sits here. It says requires Logit container image, which is interesting. We need to sort of pull into that and see how does that work. So let's jump ship. Let's go back to Logit, the paste service. This is where the jobs are defined for the Logit paste service. It's rather annoying that for some reason some of the pictures aren't showing up here. We'll just have to go on. So this is a job called the Logit build OpenDev image. This is what actually builds the paste service container image for us. You can see this actually provides the Logit container image. So before we had the requires, and here we have the provides. What's really nice about Zuul is that everything, Zuul has a sort of hierarchical job concept. So this OpenDev build Docker image is actually a very generic job that we sort of instantiate here to just build this particular image. You can see that this has a dependency on a thing called the build set registry. If you notice when we had the job up before, that the build of the container image actually depended on this build set registry. So what is a build set? The build set is this group, this whole set of testing that is happening against this one particular change. So what the build set registry is actually a registry. So a registry is a place that you can push container images and pull container images from. It's actually a place that you can push a container image for a whole set of testing. This doesn't seem to make much sense for this particular case, but here's something I've pulled out from where we use node pull. So here's the registry job. We actually build a node pull image here in this, and then we use that image 1, 2, 3, 12 or 13 times afterwards to build all these different platforms. So the building the image relies on the registry. Once the image is built, it pushes it into that local registry, and then all these jobs depend on both of those, and they actually pull from that local registry. So when we push a change, we sort of build the image once, we push it into the local registry, and then we can pull it as many times as we need with as many tests, and we don't have to build it multiple times. But you sort of still might be saying, okay, but you seem to be running across two separate projects here. You've got the Logit side where I sort of understand you're building a container image with these changes. That's fine. But how does this get across and still get tested on the configuration side? There seems to be something missing here. Well, just two more concepts, I swear. We have a concept of an intermediate registry. So this is actually a shared registry that we can push our changes into that is not ephemeral, that sits outside of our changes and allows us to pull the containers into other projects and do this cross-project testing. That's great that you can push a change into a sort of registry for caching, but you actually have to be able to find that change again. And so we use another part of Zuul, which is the artifact handling, which is where Zuul keeps metadata that jobs return, and we use that to look up the container in the intermediate registry. So let me actually explain how this works in detail. So we have our proposed Gerrit change. This was the two changes we made. We ran this job that built the container image, the build OpenDev image that we've been talking about. That gets pushed to the build set registry. That's what we've been talking about, that can be used by this jobs that are being tested right alongside that change. But we also push that change into this intermediate registry. So this is the long-lived registry. It'll sit in here. It just does like a mark sweep cleanup. It might sit in here for a couple of days until it's not used, and then the intermediate registry will get rid of it. Intermediate registry, part of Zuul, a service that can be run alongside with Zuul. But then we also return an artifact from the job with a tag that tells us where in the intermediate registry this container is that we built. So let's sort of have a look at this. Here's the build of the testing image that we want to test and deploy. This is the Zuul interface for the job result, which you can find via the same zuul.opendev.org link that I showed before. You click on that, you'll see artifacts, and you'll see we have here a sort of container image artifact. That in this case, this is really not a human consumable artifact, so it makes more sense if we just pull it on the command line. You'll see that we have this artifact type, and you'll see that it gives us a reference here so that we know where to pull it from the intermediate registry. So this is how we end up doing the cross-project testing and pulling in the changes from the Logit container pulling them in, testing them in our system configuration, and making sure that we know everything is ready to go and ready for production. So this requires Logit container image, this sort of thing that says here. What this is actually saying when we unpack it in words, it says, Zuul, can you provide me in the jobs that I'm about to run a variable that's called Zuul artifacts? And I want that to have a list of artifacts for any job that I depend on. So remember before we said that this job depends on the changes to the Logit container image. So for any job that I depend on, get me the artifacts, any job that I depend on that provides Logit container image, give me their artifacts in this variable. So you don't really have to look too much, but it's all there if you want to start digging into it. So when we run the system config run paste job, so this is the job that is going to test the actual deployment of all the changes in the Logit container. You can actually see here where it goes and it pulls from that URL that we were saying before, and it's actually grabbed that from the artifact. So it does that in Zuul jobs. I just wanted to sort of pull up the code and show you that there's no magic here. You can sort of see that all it does is goes through. This is the job that pulls the container from the separate project, and it just does a loop through the Zuul artifacts and looks for container images in the artifacts, and it pulls them locally. So we have effectively pulled in the container with the changes from the other project. And that's the container that we are now going to deploy and use in our system config test, which is going to ensure that we have end-to-end tested the changes in the Logit that we proposed in the Logit project over there. So we will run our test deployment here. I just wanted to pull out and show you that we, as part of the results of the job, we'll drag back basically all the logs you could need to debug what's going on. All the logs from starting the container and starting the services, setting up the database, all that sort of thing. And you also have all the Ansible logs that deployed these changes for you. So this is just an example of the Ansible steps that are deploying into our simulated production environment. And it will go through all these steps. If there's any problems, it'll flag it, it'll fail. You'll be able to go back, you'll be able to debug it. There's no problems, all good. You know that the container was pulled in, it started, we set up everything, everything from IP tables to Apache to Docker to the start scripts, the stop scripts, everything. And so it's all there, it's all been tested. That's just the Ansible bits and pieces. Another kind of cool thing that we do, because this is a sort of complete end-to-end test, as part of the paste test, we actually start up a headless browser and point that at the service as well. And so you'll see one of the artifacts is called screenshots, and we'll actually go and take a screenshot of the service that we set up in our production environment, our ephemeral production environment. And this is the actual screenshot here. You can see that instead of saying new paste before, now it says please enter your new paste. That was the change we made. So we have sort of 100% confidence that the changes we made are deployable, have worked. This is running now the Python 3.9 container. We know that our API change has been made, has applied. This is everything we want from our CI system. We have great confidence that everything is going to work when we push this into production. Yeah, just calling out that we did the main thing. So, deployment is really boring. We run a separate job for doing deployment. So instead of system config run paste is the job that runs on the unprivileged changes that come in. Once a change has been reviewed and committed, then a different job runs, the infraprod service paste, but it essentially does exactly the same thing, except it targets the production machine instead of the ephemeral nodes. So this is actually the top level playbook that deploys the paste service. Nothing very exciting there. You can go to our system config repo and have a look at it if you like. So, it's just two branches of the same thing. When an unprivileged change comes in, the ephemeral Bastion host runs this service against the ephemeral paste node, and that's what happens. In the production side, we run exactly the same playbook, but just against the production service. So there's nothing different, and there's very little to go wrong. Of course, I'm glossing over things. Of course, production is different to what we can possibly set up in our sort of ephemeral testing situation. A couple of things that come to mind is Let's Encrypt, or basically, SSL SSL setup of services. In CI, we just have self-signed certificates, while in production, of course, we have authenticated certificates that we use Let's Encrypt to get those certificates. So that sort of changes things. The other thing that we have to worry about in production is that, so the build set was the set of jobs that run against a particular change that comes in. We do actually have room for parallel jobs to be running in wild, in the wild. So in production, we have periodic jobs that are running. For example, the Let's Encrypt example previously, Let's Encrypt certificates expire after a couple of months. We have a periodic job that goes through and makes sure that all our certificates are up to date. So you have to account for the fact that somebody might have pushed the change while one of these periodic jobs is running in the background to keep things going. Zuul actually provides ways for you to deal with that at the Zuul level. It gives you semaphores that you can use, so jobs won't start running on top of each other. But this is something you need to deal with in production. Logs is a big one. So obviously in the ephemeral testing situation, where you're setting yourself up with just all test data, and on ephemeral nodes, we grab all the logs and everything's just put back, and you see it in your CI jobs. We don't publish the logs for the production deployments. We would like to, but of course the practicality is that you can leak secrets fairly easily from that side of things. If we focused on auditing, maybe it would be something. Maybe it would even be good, because anything you did leak, you have to make sure that you can rotate in an instant. It would be good, but it's not something we have at the moment. And also, not everything is sort of completely fault tolerant, in that we can just sort of commit a change and push it and have it deploy straight away with zero downtime. Some of our services, like Git, which runs our code browsing and stuff like that, we do run in a fault tolerant manner than that. Other services we don't, so they have a little bit more manual interaction. We consider that a bug, and we're always working to basically take ourselves out of the loop as much as we can. But there definitely are still points that sort of need a little bit more interaction than we'd like. But it's all solvable. I mean, I think that the general principle here of testing like production and pushing like this is something really quite valuable. I just wanted to show an actual practical example of how sort of someone who came along and contributed to our infrastructure that didn't have permission as such, wasn't sort of part of the existing group of people that generally work on such things. This was just standing up a service, the RefStack service. You can go and check out the change yourself. We went through a lot of back and forth. There was a lot of learning for everyone. 47, different reviews. But, because of the way that we set up this system, you can push your changes, you can see the changes. We could essentially, have our sort of simulated production environment running these changes, and the developer got a lot of feedback about, how to build up the deployment steps. And then by the time we got to the end, after all the reviews, all that was really left to do was commit and push the change, and off it went, and popped itself into production. And we sort of knew it would work because putting it into production was really so close to what we'd been testing that it just works. This is a good example of how our open infrastructure works to allow people to get in and help us build and maintain the services that we provide. So if you're sort of interested in finding out how this all actually works, you go and check out Zuul CI. There's talks there. There's specific Zuul talks that go into a lot more detail on Zuul and how it all works. VexHost is a big supporter of OpenDev. They offer a managed Zuul service. And the other thing to check out is the Software Factory project from Red Hat. That's not so much focused on this sort of CD side of Zuul like this, but if you think that this is sort of interesting technology, then Software Factory can really help you get a Gerrit and a Zuul and all these other services down there sort of deployed in a really all-in-one manner. It's a great way to sort of set up a software factory, I guess. So that's it. I'm about out of time. Thank you. I just wanted to sort of give you a bit of an insight into how we do this open infrastructure that runs on top of an open source stack. How this ability to do this cross-repo testing and this speculative testing and to test like we deploy it really allows us to have this open infrastructure. And hopefully you can see that having this open infrastructure, it's just such a force multiplier that allows other contributors to come in and help you manage your own infrastructure. And for the people that are sort of more in the weeds of it, the sort of core reviewers who are going to be looking at the changes coming in, it just takes so much load off them knowing that the CI is so good that it's going to be picking up any of the problems before they even have to look at it. To chat with us, OpenDev on OFTC, IRC, or a Matrix. There's a Zuul channel on Matrix. You'll find plenty of people who'd be happy to talk to you all about it, and that's it.
Cool. Thank you so much, Ian. That was a really interesting talk. We do have one question which will pop into the text chat afterwards if you want to join that. Okay. Yeah, thank you so much. Next up is our lunch break. So come back at 1:30 p.m. In this theatre, we've got Mike Cohen with Velociraptor digging deeper in Linux for DFIR investigation. Thank you so much for your talk, Ian. Have a great rest of your day.
Thank you.
Bye.